Alright, so today I picked up some dry ice. What I want to try doing is some of these experiments with these samples being much colder. I think that's the key, is the temperature. The temperature has to be really low.
Now on glide path, on course, over the landing threshold.
Here's what happens here when I put this brass on here. It's pretty fun. Lots of fun. And so I'm chilling. I've made a couple of special coils. They're actually coils from speakers, which I'm going to drive with an audio amplifier. And in the center of the coils are some special materials, core materials that I made, which I'll explain in a bit. So I've got a digital scale set up here, and I've got this little mechanical one. So hopefully we'll see something happen with that. And I'm going to look for torsional forces as well as gravitational forces. So I'm just going to wait for these things to cool down. I'm going to try to do some spinning these cylinders up again, but when they're really cold, see what happens. And I'm going to try, the idea is that the nuclei would polarize to a much higher degree when the lattice is very cold. So dry ice is about as good as it gets for refrigerants as far as cost, before I go into something like liquid nitrogen, which would be the next step. So it's cooling down there. This meter only goes to minus 20 degrees Celsius, and that's what is that in Fahrenheit? I don't know. So this is going to cool here. Aluminum. It's just so angry. That's hilarious.
That's farting.
Yeah, it's farting. Try some lead. Oh, lead doesn't make any noise. Oh well. Anyway, just while I'm waiting for the other thing to cool, I just want to do this quick little experiment to compare how the response of brass and aluminum chips are to magnetism at room temperature. So right there, the magnet really doesn't pick anything up, and over here is a little bit of aluminum foil, tiny aluminum chips, and so it doesn't really pick anything up there either. Now over here is the same things that have been sitting beside a couple of chunks of dry ice. So let's see how it responds. Well, the trick with this is getting it to actually make contact, because of the nature of dry ice. See, that's got a little bit on there. The aluminum is seems to be responding a little better. Yeah, quite a bit better actually. See, I'm picking up those big chips. See? That's a lot better. And again, over here at the room temperature stuff, it doesn't even really. So I'm going to cool this magnet down. See if we can get some nuclear spin orientation to help. See if we can get some gravitomagnetic from the neodymium atoms. Okay, so this brass disc I've been chilling. Got it very cold. I'm going to spin it up underneath this dish here with water and these few little particles of brass and aluminum foil, and just see what happens. And I need to get as close as possible, of course, without bumping the thing. Like that. I just put a little bit of this dry ice in some canola oil here. It's kind of interesting. It's like it gels up around, but it doesn't make any smoke or anything. It almost makes the oil kind of like a gel. Strange. Well, see if I can induce a current in canola oil. Oil should work too because it has a lot of hydrogen in it. Hydrogen protons. Yeah, too much viscosity. I want to try is to see how lead responded to magnetism at room temperature and also being very cold. So now it's cold. So at room temperature, there was no response to this stack of magnets. Well, tiny little bit, but really only about, I would expect, 20% of lead to, the amount of lead to respond to anything anyways. Oops. Alright, so that didn't make any difference. Cooling it down to, I don't know what the temperature is, probably, it's below minus 20, that's for sure. Probably like somewhere between minus 20 and minus 80 Celsius. Okay, so I've hooked up that aluminum cylinder again to my Dremel. I'm going to spin it up here and see if anything happens. Okay, first test. Here's the speaker coil. That's epoxy with manganese dioxide. Nice and cold. I'm going to set it up here on the scale. Hit it with a few different waveforms because I want to jerk the nuclei around with magnetic pulses. Alright, so here goes. So right now it's at 300 hertz, and it's a ramp waveform. So that's the magnetism going through the coil. Just going to go through the frequency range here. Sleep time, 10 seconds. So it's going up from 0 up to a few hundred hertz. See if it makes a torsional gravity field. That's what I'm going to try and see here. Something happening there? An octave here on the frequency. Looks like we're back up to room temperature. The wax and the cobalt oxide powder. All right, here goes. Okay, go down an octave. Saying minus 0.1. Yeah, I don't know. That would be too small to pick up on the mechanical scale. Sweep. It's getting hot now. I think sine waves would do anything because we want sharp transitions. Yeah, it's getting hot now. Megahertz. It's doing a sweep through multiple megahertz. Now it's going to be in the sub hundreds of kilohertz. Right there with a sharp transition. So normally bismuth doesn't respond a whole lot, or at least in my monkeying with it, hasn't done much for when I put magnets near it or anything. So, but let's see what happens here when it's cold. blob of aluminum. Minus 13 Celsius. Not that cold. Nowhere near cold enough. That's what we really want to see right there. Let's see how cold that is. Can you notice how that's not that cold? What I'm going to do here you can play with that. What I'm going to do here is similar to before. I've got that coil hooked up, and what I would like to see is this fluid circulate due to an induced gravity field, as the kinematic field or the gravitomagnetic field inside the cobalt atoms collapses, because I'm driving it with a sawtooth waveform scale to, just in case anything happens there. I doubt it, but so I'm just going to go through a range of frequencies here. Anything gets induced in there. I just noticed that. I'm going to go back down a little bit. Could just be scale noise. We'll see. Continuing on here from at 500 hertz with the sawtooth waveform. This is sugar water, and with the manganese dioxide core material. So I'm looking for some sort of induced rotation here. So I'm at 600 hertz, 650. Low frequency here. So down to, this is 8 hertz. Let's see here. There we go, 1 hertz. That's 100 hertz right there. The other coil here, this is the cobalt mixture and cobalt and wax here. Well, the other coil is cooling down again. Haven't changed the frequency. So I'm just gonna turn it up right now and see what happens. Turn up the amplitude. Now I'm going to change to the mirror image sawtooth waveform.